Today we are going to look at the quadratic formula. This formula is going to allow us to solve any quadratic equation. So in the past, we've looked at two ways to solve. Earlier in the unit, we factored, and then we set that equal to 0, and we solved from there. We got our solutions, okay? In our last section, we actually graphed. We graphed the quadratic, and we looked at the x-intercepts. Okay, we actually called them zeros. Okay, or we had solutions. Okay, so we've looked at two ways. Now we're going to look at our third way, which is the quadratic equation. Okay, we're going to use this equation. Like I said, we can solve any quadratic equation. Remember back to when we looked at factoring, we looked at quadratic equations in standard form. Last part of our unit, we looked at vertex and intercept form, but if you remember, standard form was ax squared plus bx plus c is equal to 0. And that's what we're going to use to create our quadratic formula. So when we look at our quadratic formula, the a, b, and c that we're going to see here references back to this quadratic equation. So this formula you're going to need to know and memorize, which is why it's in this nice big box here for you. So we want to have x equals negative b plus or minus, either one, we're going to talk about that a little bit more, the square root is a big square root of b squared minus 4ac all over 2a. So make sure you have that copied down. X equals negative b plus or minus b squared minus 4ac all over 2a. It's a mouthful. There's lots of videos on YouTube to help you memorize it. You're going to need to know that, okay? But we're going to break it into some parts. So this is our whole quadratic formula. But there's a piece of it called the discriminant. The discriminant is the part of the quadratic formula that is under the radical sign. So it's the part here that's under the radical sign. So it's that b squared minus 4ac. So that's what we're looking at there. So the discriminant gives us information, okay? So the value of the discriminant, if the discriminant is positive or the value is greater than 0, okay, your graph is going to have two zeros. Okay, so what that means is my parabola is going to appear on my graph something like this. Could be going down, could be in a lot of different ways, but the point is it has two real zeros right there, right on the x-axis. Okay, that's what that looks like. The other option is that your discriminant could be the same as 0, could be equal to 0. In that case, we only have one 0. Okay, and that could look like, we saw ones like this when we graphed, that could look like this. It only touches the x-axis one time. And our last case is when the discriminant is a negative number, or d is less than 0. When it's a negative number, we're actually going to have two non-real zeros. So up until this point, we've just said no solution or no zeros, but then we actually call that two non-real zeros. So the picture here, it does not touch the x-axis. So for now, we stop there. We just call it two non-real zeros. If you take Algebra 2, you go a lot more into this, but for this class, we're just going to kind of stay here. Two non-real zeros if our discriminant is negative. So for the following problems, we're going to determine the discriminant. So that's the first thing we're going to do. Then we're going to determine the number and types of solutions. So basically looking back at this chart, when I ask you what solutions are, you're going to check to see what your discriminant is here. And so how many solutions should I have? okay? And then we're actually going to find the solutions from using the quadratic formula, okay? Now this is on the front of your notes, so go ahead and flip your notes over and look at the back. Okay, so remember we are in standard form here. And we have to identify my A, my B, and my C, okay? So here, my A is 1, my B is -8, and my C is 17, okay? So my discriminant, I'm going to look at the equation. I'm going to look at the equation B squared minus 4AC, and I'm going to substitute. So my B is -8, so I get -8 squared minus 4. My A is 1 and my C is 17. So you can use your regular calculator for this. I am going to start showing you more things on Desmos. So you can use Desmos to do this. So I'm going to pull up Desmos, and to do that, remember go to LCPS Go, click on Math, and then the Desmos calculator. So I can just type in here, I'm going to do parentheses, -8 squared minus 4 parentheses 1 and 17. 1 parentheses 17. Okay, so I get -4. It says it right there. So if I come back here, so this is equal to -4. So my discriminant is -4. Okay, so I go back to my table, and if it's negative, remember we're going to have 2 non-real zeros. So I'm going to write here 2 non-real zeros. Okay. Now my solutions, we're going to write here NA. Okay, there are solutions, but we're not going to get into that right now. Okay, that gets into some other stuff, so we're just going to stop there. If you get a negative discriminant, you get to stop. Okay, so let's take a look at example 2. Again, we're going to identify my A, B, and C. So my A is 1, my B is -8, and this time my C is 16. So I'm going to use my discriminant, B squared minus 4AC. Again, I'm going to have -8 squared minus 4 times 1 times 16. Okay. And I'm going to come back to Desmos, and that's pretty much the same thing here. I'm just going to change this one to a 6, and I get 0. So notice there my discriminant is 0. So the types of solutions, I'm going to go back to my table. So if I get D equals 0, the discriminant is 0, I have 1, 0. So I should get one solution here when I solve this. Okay. So now when I get 1, 0, I have to do some more work. So I'm going to go back to my original formula that we talked about on the front. Okay, we have this whole formula. So we've done this piece of it. Now we need to just put these two, -b plus or minus the square root of our discriminant all over 2a. So I'm going to do x equals negative, and then my b, which is -8, plus or minus the square root of my discriminant, which is 0, all over 2 times my a, which is 1. And this is going to be equal to, so -8 is a +8, plus or minus the square root of 0 is just 0, all over 2. Well, if I add 0 to 8 or subtract 0 to 8, it's still 8. So 8 divided by 2 is just 4. So x is equal to 4. I got my 1, 0, that is 4. Okay, and my last example, again, same thing, I'm going to identify A, B, and C. If I notice here, it says 2x squared minus 8x equals 2. I'm not equal to 0. And we saw this with factoring. It has to be equal to 0. So I'm going to subtract this 2 real quick. So I have 2x squared minus 8x minus 2 equals 0. These are not like terms. So from there, if I think back to my factoring unit, if I see 2, 8, and 2, I can divide all of these by 2. And I'm left with x squared minus 4x minus 1 equals 0. Okay, in our factoring unit, we would have kept factoring, but we're going to use the quadratic equation this time. Okay, if you didn't see that, it's okay, but this allows you to have some smaller numbers. So my a now is going to be 1, my b is -4, and my c is -1. So I'm going to find my discriminant. So remember, that's b squared minus 4ac. So my b squared, so I have -4 squared minus 4, my a, which is 1, and my c, which is -1. Okay, I'm going to come over to Desmos and type that in. So I have parentheses, -4 squared minus 4 parentheses. My a was 1, and my c was -1. And I get 20. Okay. So my discriminant is 20. So I'm going to go back to my table. So 20 falls here. It's positive. It's greater than 0. So I'm going to have 2 real zeros. So this time I should get 2 numbers. Okay. So now I have to continue with my quadratic equation. Now I'm going to plug that into my quadratic equation. X equals, I have -b, so negative parentheses -4 -4 plus or minus the square root of my discriminant, which is 20, all over 2 times my a, which is 1. Okay. So let's simplify that a little bit. That's going to be equal to -4 is a +4 plus or minus the square root of 20 all over 2. Well, in our last class, we looked at simplifying square roots. And so I want to see if I can simplify the square root of 20. So I'm going to come down here so I have some room. So x is going to be equal to the 4, stays the same, 4 plus or minus. So if I think about root 20, okay, I can go back and look at my list. So looking at Desmos, remember my list, I can get y equals x squared. Look at the table. And I can make my list longer by just entering down. So 20 would fall right here. So I'm going to start with 16 and work my way up. So 20 divided by 16. Nope, that doesn't work. The next one is 9 and then 4. 20 divided by 9. Nope. And you probably know off the top of your head that 20 divided by 4 will work. And we get 5. So we've got the square root of 4 times 5 all over 2, which is equal to 4 plus or minus. The square root of 4 is just 2. This is what we simplified last class, all over 2. And lastly, if you can simplify that, you do. And we do that with this little heart. So if you notice, I have a 4, a 2, and a 2. So if you can draw a heart, it is Valentine's Day soon. So if we can draw a heart and we can simplify or divide all of these by something, so we can divide those all. So we have 2 plus or minus the square root of 5. 4 divided by 2 is 2, and these 2 will cancel. 2 divided by 2 is 1, and 2 divided by 2 is 1. So there is my solution. So x equals 2 plus or minus the square root of 5. And I know we said we'd have 2 real solutions, and it looks like there's only 1 here, but plus or minus, this means we have 2 plus root 5, and we have 2 minus root 5. Okay? If you were to have a regular number there, you would then add those, but square roots, we get to stop there. Okay? So now that you've taken your notes, go ahead and work on your practice problems. There is an exit ticket that is on Google Classroom for you to do. You may use your notes and your practice to do your exit ticket for today, since I am not there, but you will not have your notes or practice for your entrance ticket. So please make sure you do your homework, or you come see me if you have any questions. I will answer questions on the homework before you take your entrance ticket on Wednesday. All right, have a good afternoon.